Somebody once said that he that does not know and does not know that does not know is actually the true definition of a foolish and ignorant individual. One of the greatest decisions that you've made is taking around on this channel, because all we do on this channel is to share insightful information with you, because knowledge is power and there's no knowledge that's a waste. Good afternoon, good morning, good evening, depending on the part of the world you are joining in from. And in this episode of this lesson, I'm going to be showing you one insightful solution that will blow your mind. Now, I don't know if you are a mathematics enthusiast. We have what we call a standard integral. For me, I'm a logical thinker, so if back then I used to feel if we have standard integral of 1 over x, normally you know that when you integrate 1 over x ds, if I don't have to do anything, this is called standard integral. The value is ln x plus c. This is actually a standard integral, which means that if you differentiate it, because the derivative is the opposite of integral, so if we differentiate ln x, we arrive at 1 over x. But then the question is, what is the standard integral of ln x? If we have standard integral of 1 over x to be ln x, now how do we now get standard integral of ln x? The answer is this: there is no standard integral for ln x. So we need to work it out using a particular method, and I will show you in a moment how you go about finding the integral of 1 over x. So let's just type into it quickly. Integral of 1 over x dx, that's all I want to do. Sorry, I beg your pardon. Integral of ln x, not integral of what is ln x. We know that already. So integral of ln x, that's what I want to do. The x. How do we go about integrating ln x dx? And the method we are going to be using is a method that most likely you've heard before, but it's just that you might not really know that that's the method you need to use. And that method is integration by parts. So when we are using integration by parts to integrate ln of x. Now, how do we go about that? Consider this function x e raised by x dx. When do you use integration by parts? When you have two functions, you have to integrate product of two functions. One of them might be quite easy for you to differentiate, while the other might be maybe it has standard derivative or a standard integral. It doesn't really matter. But when you have product of two functions, then one of those methods that should come to your mind is integration by parts. Now, how do we integrate by parts? This is general formula for integration by parts. Integral of u dv is same thing as 2 minus integral of v d. What this entails is that this is the question that you want to solve. One of the terms should be u and the other would be dv. Now the choice of which one is u and which one is dv lies solely on you. There are times that whichever way you arrange it, you still arrive at the same answer, but there are some times that if you misplace them, you will not actually arrive at your answer because it's difficult for you to integrate. Now, what are the methods I may have found out, and it has been working for me for years now? And that method is such that you can actually decide which one is best as you, which of the functions can you use as u, and which one can you use as dv. And I'll give you just two things. Now the first thing is, if you observe that one of the functions, when you integrate it, it will keep having like increasing power. Many a times it might be like an indication that that function cannot be your dv, because cannot be your u, because you don't want to differentiate a function and the power will keep increasing. That's number one. Then number two, there are times that you look at the other function. If it is easy for you to integrate, it might be a pointer to you that that function should be your dv because you can easily integrate it. So once you are able to get one that is best as either u or dv, then the other one will just follow suit automatically. Now for this, I will simply say that let u equals to x and let dv equals to e raised by x dx. So once I have this, I can now differentiate this. So du will give me 1x, and I will integrate it as an integral of d equals to integral of e raised power x. So if I integrate dv, of course, that will give me v. And integral of e raised power x is a standard integral, so it will give me e raised power x. So now I have my u, I have my v. This is my u, this is my v, and I have my dv. So then I can now use this formula to simplify that integral. So that being said, we can say that integral of x e raised power x dx will now equals to our u is x, so we have 2v, v is e raised power x minus integral of v du. Our v is e raised power x, and our du is 1 dx, so multiplied by power 1. So when you simplify further, we have x e raised power x minus integral of e raised power x. And of course, know that integral of e raised power x is a standard integral, which will give us e raised power x. So the required integration by parts will be e raised power x minus e raised power x. So that will be the answer. So without further wastage of time, now let's now integrate ln x. We want to integrate ln x by parts. So we have integral of ln x dx by parts. We can rewrite this as integral of ln x dx equals to 1 multiplied by x dx, because if you look at it literally, you observe that it's just one function, and like I said earlier, you need two functions for you to be able to consider integration by parts. So all I'll just do is I'll just manipulate the given function in this form. So we have 1 multiplied by ln x. Now what we do now is we need to decide which one will be our u and which one will be our dv. And in this case, so that I will not run into trouble, I prefer to say let my u be ln x, and let my dv be equals to 1 dx. Now the reason is this: if I use ln x as my dv, of course I know that I'll have to integrate, and integrating ln x is as good as going back to where I'm starting from, because what I'm trying to solve is integral of ln x. I want to avoid whatever will make me integrate ln x. That's number one. Then number two, if I should make 1 my u, of course I need to differentiate u with respect to x. So if I do that, differential of this constant will be 0, and I don't want to have a solution of 0 at this stage. Anything that makes it to have 0, that means that I will run into a very huge problem as I proceed in the solution. So let's go ahead. Now u equals to ln x. Let's differentiate u with respect to x. So we have u equals to 1 over dx. Okay, there's no need for dx. Okay, 1 over x dx. Let's just do dx. The u is 1 over x dx. Now somebody might be asking, why do we just conclude that it's 1 over x? This is standard derivative. Integral of, I said earlier that integral of 1 over x dx is a standard integral, which is the same thing as ln x plus c. So if you integrate 1 over x dx and it's giving you ln x plus c, that's a standard integral. It implies that when you differentiate ln x, you will get 1 over x. So you just call up this solution directly. You don't need to solve anything. Then the other part is integral of dv equals to integral of 1x. And when we integrate dv, we have b equals to x. So then we can now use the formula for integration by parts. We have u dv will be equals to u minus integral of v du. So then in this case now, our u is ln x, our v is x, then we have integral of dx, our du is 1 over x. So this x, we cancel out this x. Then we have x ln x minus integral of 1. Of course, we know that integral of 1 is x. So we have minus x plus c. So therefore, integral of ln x dx will be equal to x ln x minus x. That's the answer. You can see that it's quite tricky, but then very straightforward, and I believe it's easy to comprehend by anybody. Thank you very much. That will be all in this lesson. Thank you very much for your time. I believe you've gained quite a number of things. So please do well to like this video, share it with your friends, your neighbors, even your enemies too. And don't forget to subscribe to the channel. Thank you very much, and I'll see you in the next tutorial.